So we're getting an update on where we're at on the remedial design process tonight. Generally, we'll just talk about an overview of the site for those that are less familiar with the Willamette Cove site. The pre-design investigation activities, which is what we worked on over the course of 2022 and into early 2023. And then what we've got left to do to complete our supplemental pre-design investigation, which is kind of our last big investigation piece before we get into 30% design, which we're going to start on here in the next month or so, start working on it. So an overview of the site for those that are a little less familiar. This is the site that was shown in the record of decision. The different colored blobs on that are based on the record of decision, different technologies they thought were likely to occur within these different parts of the project area. And the red line is the project area boundary for the site. It's roughly a 46-acre site, with 40 acres of it being water and roughly 6 acres of it being the river bank through the adjacent to the Willamette Cove project. So the supplemental pre-design investigation, why were we out there sampling? We were out there sampling to fill data gaps that we needed to move forward on the 30% design process and to delineate the extensive contamination. In 2020, we did our first initial investigation. We did a lot of sampling then. We understood pretty largely the extensive contamination, but like anytime you go out and do a large investigation, you find some spots where you need to bound that contamination a little bit more clearly. And so we were out there to do that. And then again, it's part of the design. What were we sampling out there? We sampled a wide variety of media. In the 2020 investigation, we sampled a few types of media. The 2022 really expanded the investigation into a lot of areas. It included soil sediment and core water sampling, which is the water that's in the space within the sediment. Then we have in 2022, we had not done our biological site investigations to understand baseline conditions at that time. So the 2022 investigation, we did that. And then how do we do sampling? There's multiple technologies throughout for all these different investigations and using best practices for data collection that has been used and typically used for data collection of this type. And then following procedures and approved plans, working with EPA. So timeline-wise, where we're at on the site, we've moved along quite a bit. It doesn't probably feel like it to everybody who's had to deal with this for a long time. We started at early 2020 with our first work plan and implementing all that initial investigation in 2020. We developed a couple more plans and reports from them. We implemented we're in the process or late stages of supplemental, writing the report up to present that data, and then getting ready to start 30% design. So we're right there in the process. Again, we did a lot of different activities in this. Without getting into this in detail, just to give you a sense of all the different programs that were part of the supplemental activity. We had 9 large programs that we had as part of this. In addition to that, one of the things that we heard from community is around local hiring engagement. One of the things GSI did, we worked with Green Workforce Academy, which was amazing to help identify a person to train and hire. They ended up being hired as a GSI employee. We brought them on various parts of all the field investigation, get them experience. And the goal of this was somebody that was interested in the environmental field, but literally had no experience working in this. And they were a part of our project team when we were out there in the field doing everything we did, just like anybody who had worked for GSI for a lot of years or one of our consultants that were partnered with us. So they got to engage on a lot of different activities. And then, so what are some of the major programs? I made these slides as we move through this more visual heavy with a little less information. So feel free after this, if you have any questions, when we have the breakout room or questions, feel free to ask any questions. So first thing, surface sampling, we did additional surface sampling in areas where we still had additional data to collect. They used what they call hour grab sampler. It's basically this scoop bucket that opens up, it grabs the sample to the top foot, and then you do it over 3 points in a small area, and you put that together and get the sample. And then in a couple of locations, we weren't able to get a good sample due to coarse material or something like that. So when we went to do our subsurface sampling, we did with the sonic drill rig, we collect our top foot during that process. And we also had some locations where we go with the diver and they go down and they push this core tube down a foot and they collect the sample there. And those were where we did pore water samplers. So we got samples right there when they were installing core samples. For the subsurface sampling, We used a sonic drill rig. So with the sonic drill rig, they put it on the barge, and this is what they were talking about during the event in the summer. And then we pushed down with the core, and we collected this core, and it comes out of the tube, and you put it into a bag, and then you have it over the course of a link, and you analyze that sample. So other things we did is we sampled the riverbank. One of the things that didn't happen in 2020, because we were still working on the details of how we do it, is the riverbank sampling. So 2022, we did that. What we did is we took transects every 150 feet along the riverbank, and then we collected a sample, 3-point composite sample, so grabbed 3 samples within a small zone. At the top of the riverbank, we did the same thing at the middle of the riverbank and the bottom of the riverbank along every 150 foot of the riverbank. But we got a long stretch of riverbank, so there's a lot of samples we collected there. In addition, we have a few beach areas. One of the beach areas where we were able to access with a drill rig. This is the one in the Inner Cove that people are probably most familiar with. We did a couple cores in that area there. And then in all the beach areas, we have 3 beach areas. We did what they call multi-composite point sampling, where you collect 30 different points, you composite into a single sample, and analyze that to get a general sense of what the concentrations are in that surface material. The results of the historic sampling has been done. The sampling was done in 2020, and then all the data we had through the end of 2022, we ended up putting in this map and creating this. The black dots represent locations where we had exceedance of at least one contaminant somewhere within that depth zone. It may not be in the top foot, it may be at a deeper depth. And the white indicate locations where we didn't have any exceedance of any of the primary contaminants. What's really, I think, important to note is it kind of gives you that sense of those areas where EPA identified in the record of decision as likely areas where remediation would need. Probably it falls pretty close within that initial identification. The other thing it says is there's been a lot of sampling that's been done over time at this site. So I think it's kind of helpful in a couple of ways to show that. Other things we did is geotechnical evaluations. We just kind of trimmed it down to a couple that we thought were most interesting to present to the public, but they're even more geotechnical. This is an evaluation of the stability of the bank. One of the things we learned about this site, from the time we started and did our initial visual evaluation, is that there's some issues with bank stability that we're seeing within the riverbank of the site. So one of the approaches that you do to evaluate that is a very technical approach where you go through at the same 150-foot transects. You look at the angle slope, you look at the spill, you look at the material in there, and then you come out with the score sheet, which is the bottom part there. So a geotechnical engineer went through the site at every 150-foot point and evaluated these. The results of that in general are a lot of the banks had moderate to extreme risk of future slope failure along the riverbank. That shouldn't be surprising to a lot of people. A lot of the riverbanks, when they pour them, are over steep riverbanks. Another thing we did, I thought was an interesting one of our field events that we did that I thought was an easy one to show a visual of kind of these outputs that you don't really see. There's this cable, you'll see it here. They put this cable, drop it down in the water, they run it along these lines here, and then they run current through this, and then it gives this output that they see on a graph. This output was used to tell us, one of the things we had questions of, is there bedrock at shallow depths within our project area that we may have to consider if we did dredging that, we may hit a point where we hit bedrock. And so you see these dark red areas versus these light colored areas. These may be indicative of bedrock. We got to do a little bit more evaluation, but that's kind of the output of that. And I thought that was an interesting one to add to this. Again, we did some other geotechnical evaluations, but those were two that were the most interesting. Pore water, groundwater investigations. This was a pretty extensive program. We did some pore water sampling in 2020, and then we expanded upon this program in 2022 and did some additional data collection to help identify the most ideal locations to place the pore water samplers, because we want to get the best data we can get from those pore water samplers, and you ideally want to put it in a place where groundwater is moving up through the sediment and into the water column. So we did this trident probe study. This trident probe study helped identify locations where we thought groundwater movement was strongest. And then based on the results of that, we worked with EPA to identify places to put the seepage meters. These seepage meters actually sit down on the sediment surface, and then they actually monitor how much water moves through from the groundwater through that shallow sediment and up into the water column. So you get a sense of the rate of movement of groundwater into the river system. And then based on that data, we defined locations where to place the pore water samplers. So everywhere where we put one of those seepage meters, we placed the pore water sampler, in addition to some pre-identified areas where we knew there were more elevated concentrations in the shallow sediment. So 12 of them were placed with these same locations as seepage meters, and the rest were these pre-identified locations. And you basically take a rod like this. It's kind of a plastic rod that's formed in a 3D printer, and you push it, literally push it down into the sediment, and then you've got the screen here where it's in contact with that sediment surface, and it leaves the contaminants on the sediment, and then you extract it back off, and you measure it, or on the other side of it, there's a reservoir, and through an osmotic process, you get the contaminants to move into that reservoir. And then what I think is a really nice addition to what Laura talked about earlier during her presentation is one of the things that we're looking at as the biological conditions. We want to know the existing conditions and where there's opportunities as part of our design process to look for habitat improvement. So in order to do that, you've got to first look at the existing conditions. So we did a trees plant survey, and we inventoried any tree that was on the riverbank or within 50 feet of 20 feet at the top of the riverbank to just get an inventory of what's currently there. Any tree that's larger than 6 inches. Then we did a visual survey looking for rare plants and any noxious weeds. What we found is there's a lot of variety of tree species that are within the Willamette Cove upland boundary with the end water along this riverbank and near the top of the riverbank. We didn't find any rare plants within the zone. We looked a little bit deeper back, I believe, on the plants than the trees. There was a lot of invasive species. I'm sure nobody's surprised by that. A lot of English ivy and Himalayan blackberries. These are things we see common in these riparian zones. So this is just to give you kind of a quick visual. So this is the putting it into our GIS software and then doing a map out of that. This is everywhere we found trees that were greater than 6 inches, and the different colors and the different shapes identify different varieties of trees. And that was the eastern half of the project area. This is the western half of the project area. So quite a bit of trees. And then one of the other things we looked at is the wetlands and waters delineation. We wanted to know, were there any existing wetlands there that we would have to protect or we'd have to work to improve. What we found was there wasn't any current wetlands identified within the project area. But the other part of this was looking at that kind of what is the water transition zone where, because the river changes in elevation, what zone gets wet over different periods of time. So your ordinary low water, ordinary high water, trying to delineate that specifically within our project. So those were some of the biological activities. We also did an in-water survey looking for in-water habitat within it. So looking for how much plants are growing within that shallow in-water zone, and looking for mollusks and other things like that. Trying to see the diversity that's there. So there were some other biological activities. So what we got remaining to do is just a few things left. We're getting really close. We've got bird surveys, which we needed to wait till spring to start doing this. We're going to do our next bird survey pretty soon. And then we'll do one more bird survey before we complete our report. We've got to do, and in fact, we've been working on it this week, is sediment dewatering study. If we remove the sediment out, you can't take it to landfill in a super wet state. So we're doing some studies to determine what type of reagents we can add, how much we need to add to dewater it, and get it to a state where you can take it to landfill. And then what they call dredge elutrate test. That's if you disturb the sediment while you're dredging, what would end up in the water column, trying to understand how much ends up in the water column and what the concentrations of that water sediment mix that's in the water column. Borrow materials, trying to figure out sources that we may use in the future for backfill and what the concentrations are that. And then material handling and resuspension. So this is tied to like what classification would this material have, and what making sure that the landfills, that we wouldn't assume would be able to take it, that it fits within their ability to take it. And then we got to, process, validate our sample data and get this report. So again, we're getting pretty close. Thank you.